In comparison activities, comparing area measures is more of a conceptual challenge than comparing length measurements because area comes in different shapes: circles, squares, rectangles, rhombuses, parallelograms, and so on. A good activity would be 18.15 on page 474. You could cut a large number of rectangles from a rectangle of the same area. Each pair of students needs 6 rectangles. Have them fold and cut the rectangles on the diagonal, making 2 identical triangles. Next, have them rearrange the triangles into different shapes, including back into the original rectangle. The rule is that only sides of the same length can be matching, and they must be matched precisely. Make sure you discuss area of each. Does one shape have a greater area than the rest? How do you know? Make sure students explain which shape, after they've cut it on the diagonal that they made, has the biggest area. A triangram, an ancient puzzle, can be used for the same purpose. A standard set of 7 triangram pieces is cut from a square, as seen in the green figure. 2 small triangles can be used to make a parallelogram, the square and a medium triangle. This composing permits similar discussion about the pieces having the same area but different shape. 18.16 on page 475, transgram areas. Give students outlines of a transgram shape. As shown in the figure below, you can ask students or groups to estimate which shape has the largest or smallest area. Then let students use transgrams to decide which shapes are the same size, what's larger, and what's smaller. Make sure they justify their conclusions. Using physical models of area units. Tiles. Although square tiles are the most commonly used tool for exploring area, anything will work that fills up area, such as sticky notes, newspaper, floor tiles, or playing cards. Students can choose a unit of measures, such as surface area in a room, such as desktops, bulletin boards, or book covers. In the figure, you notice they have a shape. Kind of looks like a rectangle plus a triangle. They put a bunch of sticky notes or square tiles in, but there's areas that they still need to fill that are not full squares. There is about 1/2 of a square in the corners, in each different corner, so all the other, they count as 1 square. Some other spaces count as 1 square, but they may not look like a 1 square. They're just 2 shapes put together. The goal of this activity is to apply students' developmental concepts of multiplication to areas of rectangles without introducing a formula. In order to count a single row of squares along one edge and then multiply by the length of the other edge, the first row must be thought of as a single unit that is then replicated to fill the remaining rectangle. Students may attempt to draw the squares in. However, many use rulers to determine the number of squares that will fit along one side, and from that used multiplication to determine the total area. So in the figures below, they measured one side with square tiles, 7. They measured the other side, 7. 7 rows of 7, so it'll be 7, 7, 7, 7, 7, and 7 would be 49. And the other one, they have the first row is done, which is 10, and then they'll have 5 separate rows of 10, which makes 50. Perimeter is a length of measure of distance around a region. A hint for helping students remember the concept of perimeter is the word rim is the word in perimeter. Rim is a round circle, so it's around the rim. In the figure on the right, you'd have the rim or perimeter of 5, 13, but the other 2 sides aren't marked, but they're identical from the opposite side. So 5 would be 5, 13, 13. So then add them up. Or you go 13 times 2 to get 26, 5 times 2 to get 10, and then add them to be 36.